left channel, right channel, center.
ENVTuber 一問一答自己紹介
Yeah, and the tape's
それじゃあ
rolling.
行くよせーのお名前は
Katt Phloxworthy.
呼び方は
Just Cat is fine.
あなたは何系 VTuber?
Nerdy cat girl who features spaceflight.
誕生日は
May 4th.
年齢は
Older than Pneumatic.
性別は
Transgender
身
female.
長は
4'11".
出身は
Sacramento County.
チャームポイントは
Zylog hair clip.
突然ですがモノマネどうぞ
Yeah, what's up, Dash?
活動場所は
Twitch, Twitter, YouTube.
はじめの挨拶
Thank you for joining me.
終わりの挨拶
Bye.
推しマークは
Not at present.
配信タグは
Cat-like feed.
ファンアートは
Cat pics.
ファンネームは
Cat's apprentices.
好きな色は
Iris Indigo.
好きなことは
Vintage computers and
得
video.
意なことは
Technology.
ここで一言愛の告白好
I love you.
きな食べ物は
Ethnic foods.
好きな飲み物は
Craft soda.
好きな漫画は
Pizza 10.
好きなアニメは
Planet.
好きなゲームは
Left 4 Dead 2.
好きな音楽は
Classic rock.
苦手なことは
Human stupidity.
尊敬するのは
Space fairy people.
叶えたい夢は
ISS crew
最後にみんな
interview.
に一言どう
Thanks
ぞ
so much for your support and a final status check.
Go Atlas.
Go Centaur.
Go Katt Phlox.
You have permission to launch.
3, 2, 1. RD-180 ignition. Booster ignition and liftoff of Atlas V and Centaur. Hello, everybody, and thank you so much for joining me. Hi, Katt Phloxworthy here. Hopefully, this time with a launch that'll actually get off the ground. We are about to join. Hey, KF16, how are you doing this evening? And like Red Blue Fire says, fingers crossed that this one actually launches. But apparently, everything is go for launch, including weather, the range, as well as the payload and rocket, which is the latter one is still in the process of fueling, taking on propellant. And like I said, the next major event on the next major milestone on the timeline will be at T-7 minutes, where they will do engine chill, where they will flow liquid oxygen into the turbopumps to condition them, getting them down to operating temperature just in time for liftoff, because you do not want to have thermal shock the minute you start flowing all that cold liquid oxygen through there. And in the case of what would have happened with New Glenn, it would have also been liquid methane, which is also very cold. I'm not sure if it's as cold as liquid oxygen. I've been excited to see about Falcon 9 in a while, since they launch 3 times a week just or more just for more Starlink. Now, yeah, that's one of the reasons why I really don't cover it, because it's gotten so routine, it's like ridiculous. So, yeah, and I have other reasons, but I'm not going to go into that today. But right now, we're going into it mainly because what's going on here is they have 2 lunar landers going up this evening. Both of them, I believe, at least one of them is involved in NASA's commercial lunar cargo program. This is probably head of the whole the Artemis program, which right now, from what I understand, Artemis 2, which will take humans on a flyby of the moon for the first time, a first planned flyby at least, not until 2026. So we will, so we'll see what happens and see what's going on here. So anyway, we'll be joining them right now. We're going to be joining NASA and their coverage. So here we go, NASA and SpaceX's coverage. Stand by. I may actually have to do a little bit of jockeying with levels, so please bear with me.
The Lister drill will be running. You know, there might even be some dust from landing.
Okay, I need to unmute this.
We'll try to get a lot of dust on your payload to help you out.
I appreciate that.
All right, very
We
good.
wanna be dirty.
I want one of these for my entire house. And just punch it and all the dust goes away. Then you really have something. We are looking forward to this experiment. Thank you, Dr. Charles.
So in the meantime, we are watching. They're talking about. I didn't actually check the audio on that one, because apparently they're doing some experiments on these payloads. There's another one called. This one is the main payload on this one is Firefly Aerospace's Blue Ghost on mission 1 with another one underneath it in the payload adapter called a very small one called resilience.
Our moon. It seems so close in the night sky, but getting there is really hard. But what
Yes,
if
it
there was
is.
a way to change that?
Like Kennedy said, we went there not because it was easy, but because it was hard. That's the one.
As NASA
Octo
sends
R.
astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
And from what I understand, the total travel time will be about 45 days. It's going to be a little different from, say, a crewed flight, which would be a very direct flight, where they basically do enough delta V to push us out of lunar of Earth orbit, then do a really quick retro fire to bring it into lunar orbit.
All this work over the last few years is leading to this moment.
So what they do is they do a lot of smaller burns with I imagine with the spacecraft itself.
Operators, technicians, and support staff that have been working tirelessly to make this.
And Firefly is also the one of the main contractors, along with Northrop Grumman, to create the new generation of Antares. It'll be different between the two landers too. Hakuto-R will have much longer transfer because it'll use a ballistic capture. Oh, so in other words, it's just going to go straight into there without any manner of what am I trying to say? It's not going to be doing multiple orbits, right? It's just going to go straight in, right?
So just excited to finally start our journey.
And we're looking live.
And we're coming up on engine chill at T-minus 7 minutes, where they flow some liquid oxygen into all 9 Merlin 1D engines at the base of the first stage to thermally condition the turbo pumps to accept there we go, T-minus 7 minutes rather. There's the call. Engine chill has begun. They're flowing liquid oxygen into the turbo pumps to thermally condition them ahead of liftoff at T0. They ignite it just a few seconds just before, and then, of course, let everything go at T0.
You've launched before, but this is the first time that you're launching to.
And the next major event that's coming up is at T-minus 4 minutes 30 seconds, where they do the strong back retract, which is that girder-like structure that goes up alongside the vehicle, feeding it with umbilicals for propellant, electricity, gases, and sometimes even air conditioning.
You get to look up at the moon at night and
I have a hot take Alpaca would be a better lander than Starship because it isn't 50 feet tall and is low profile and could be modified to carry modules down instead of a crew cabin. Well, I guess we'll see there. It'll extensively use the Lagrange points to minimize the delta V requirements, but that means it won't capture into lunar orbit for probably 3 months, I think. That sounds about right. Basically, try and consume your propellants, because, as a matter of fact, that's how the James Webb Space Telescope is staying there and in place. It's in the, I believe, the L2 Lagrange point. And Alpaca was not selected, sadly.
And the moon was looking
great. And basically, that's a point where all the gravity forces are pretty much nil, and any kind of thruster firings are used just for station keeping and making sure that it's pointed the right way.
which is just below the fairing.
And
will begin to open
but
up.
basically,
Once
yeah,
those
in that
clamp
area,
arms
you
open
won't have
up,
to worry
then
too
we'll
much
begin to
about
move the
gravity
strong back
perturbations
away,
of your
slightly
of the
from
position of the vehicle.
That process will take about 20 seconds. Vehicle, the TE or transporter erector will be just about
T minus 5 minutes and counting.
Vehicle. And then at
I do think Blue
T0,
Origin Lander
we'll
is
move it
the interesting
about 45
interesting with engines and
above
fuel above the
pad deck.
cabin. Oh, interesting.
And that will make the
They
way
have just
for
started to
liftoff of Falcon 9, and we did hear that
pressurize the
call out
tanks in
that
advance
we are
of strongback
preparing for
retract,
strongback
which will happen in
retraction.
just about 10 seconds from now.
Should be coming up here in about 20 seconds.
First thing that'll happen is that clamp just below the
strongback
fairing
is that
will
vertical
start to open.
structure just behind the vehicle that you see there on your screen.
Strongback lower has started.
They have just called the beginning of strongback retract. Like I said, first thing that will happen is that clamp will open.
What you're going to see is those clamp arms just below the fairing are going to begin to open up. And once they're fully open, that'll make way for the transporter erector to move away from the vehicle.
And usually there it goes, and it'll angle back about 2 degrees, with it angling an additional 43 at the time of liftoff.
Propellant, electrical, and gas lines to stage 2, as well as the payload.
And all those clouds that you're seeing is boiling off oxygen, and they're always topping it off. And they don't do this; they don't need to worry about this with RP1. In fact, they actually cool down the RP1 if for no other reason to put more of it on there. But they can't do it too. They can't cool it off too much, or it'll start to turn into a jelly practically. Because otherwise, RP1, which is essentially highly refined kerosene, will be a liquid at room temperature. And there goes the strongback. It is retracting.
And once Falcon 9 commands for liftoff, hydraulic cylinders pull the strongback even further away, again to that position about 45 degrees above the pad deck.
Okay, starting at about real soon, they're going to start calling off LOX load on the first stage being complete.
Oxygen loading completion at the T-minus 3 minute mark.
T-minus 3 minutes and counting.
Now, for some reason,
Stage 1 LOX load complete.
There's the call. The
Stage one liquid oxygen loading is
The
now
first
complete.
first
For some
stage is
reason,
now
we do
fully
not launch
loaded
today.
with
We will have a backup
RP1
opportunity
and
tomorrow,
liquid oxygen.
January 15th
And
at
about a minute or so
10:09
later, we
p.m.
will
Eastern
about half a minute or so later, we will hear the call for stage
Currently,
2
weather is
liquid
green
oxygen
and the
load
range
complete.
is ready to support a T0 of 10:09 p.m. Eastern time. And the landers continue to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. Next coming up will be at T-minus 2 minutes. We should hear the call out for propellant
Stage
loading.
2 LOX load complete.
There's the
Right
call.
on time.
LOX load is
That
complete on
stage
second
2
stage,
LOX
T-minus
load.
2
That
minutes
means
and counting.
propellant loading is now fully complete.
The next
on
major
Falcon 9.
milestone on the
Vehicle is now
timeline is
fully loaded
T-minus
with
1 minute,
1 million
where
pounds of
startup is
kerosene
called.
fuel and liquid
The computers
oxygen.
aboard Falcon 9 will take over the remainder of the countdown, monitor the health of all systems aboard Falcon 9, and stopping the countdown in case there's a problem or any kind of anomaly.
And just a correction, it is 1:11 a.m. Eastern time for liftoff tonight.
T-minus 90 seconds and counting.
Gas launch closeouts has started.
Gas closeouts have been called. They should also be venting out the remaining liquid oxygen in the lines out the TE.
Venting coming from the transporter erector.
Coming up on T-minus 1 minute was startup and also propellant tank press.
In preparation for liftoff.
T-minus 1 minute and counting.
Falcon 9 is in startup.
There's the call. Computers aboard the vehicle have taken full control of the remainder of the countdown and are monitoring the health of all the systems and now waiting on launch director call.
LD, go for launch.
There's the call. Launch director has called everything as go for launch.
As Falcon 9 takes our 2 lunar payloads out to space.
T-minus 30 seconds and counting.
T-minus 30 seconds.
20, 15,
T minus 15.
10, 9, 8,
8,
7,
7,
6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of Falcon 9 carrying the Firefly Blue Ghost Mission 1 flight on the way to the moon, along with resilience below it, and the vehicle has cleared the tower. And there's a view from the first stage. Vehicle should be pitching down range right about now, placing it above water in the event of an abort scenario. At about the T plus 50 second mark or so, the Falcon 9's Merlin 1D engines at the base will throttle down into the bucket, reducing aerodynamic stresses on the vehicle as it gets ready to enter the area of maximum aerodynamic pressure, or max Q, at right around T plus 1 minute to 1 minute 10. Everything is nominal, power and telemetry nominal.
Engine air pressure is nominal. Vehicle is
And
supersonic.
it has just breached Mach 1, ahead of the entry into the area of maximum aerodynamic pressure, or max Q.
And we are coming up on max Q. This is the largest structural load that the vehicle will see.
And it's also the biggest milestone during the atmosphere. There's the call. Max Q has been reached. It is one of the biggest milestones that an atmospheric flight of a rocket will encounter.
That'll be MECO, stage separation, and SES.
Got about a minute left in the burn, after which point they have MECO, main engine cutoff. All nine Merlin 1D engines will shut down to slow the vehicle down in advance of separation of the stages, sometimes called just staging. And then shortly after that, ignition of the Merlin 1D vacuum optimized engine, or MVAC, at the base of the second stage. They should also be doing engine chill on it before very long, like the ones they did on the 9 sea level Merlin 1Ds at the base of the first stage.
We will ignite the MVAC engine on the second stage, and shortly afterwards we will have SECO, where the vehicle will coast. So we are coming up on those three events that I just mentioned: MECO, stage separation, and SES-1 in just about 20 seconds from now.
We're coming up on MECO shortly.
Some really cool tracking views here of Falcon 9.
Beautiful view from the vehicle from the ground. Coming up on MECO.
MECO.
They're calling MECO.
Confirmed.
View from the interstage at the top of the first stage on the left, from the second stage itself on the right. We now have ignition of the MVAC engine, that green flame being a combination of triethyl aluminum and triethylborane, a cocktail sometimes called TTEB, igniting the liquid oxygen and the RP1, powering the MVAC engine.
MVAC engine has ignited, again carrying the 2 lunar landers aboard Falcon.
And we see the grid fins extending on the first stage on the left, and those will take authority once the vehicle starts a little bit further into the atmosphere, right around 50 kilometers or so above the planet, or probably a bit lower than that.
We will also have fairing deploy. We have the fairing,
and we're coming up on fairing deploy before very long. The first stage is already, both stages have reached the Kármán line, 100 kilometers above the face of the surface of the planet. We have fairing jettison coming up shortly. There's the interior of the fairing. There go the fairing halves. And those will be retrieved for another reuse.
And a really cool view of the payload.
And then that's the engine bell of the Merlin 1D vacuum optimized engine. There's also a manifold at the top which takes exhaust from the turbo pump and routes it into the engine bell, cooling it down using what is called film cooling, basically an inert gas seated between the the engine bell and the flame itself. And the rest of it is, you see that red hot niobium bell, that is doing radiative cooling.
We're currently in the first of 3 planned MVAC burns.
Oh, there are a total of 3 burns on this mission.
You should see on your screen the first stage's entry burn. Now that entry burn is where we ignite 3 of the Merlin M1D engines, and that's going to be the E9 engine plus the E1 and E5 engines. Now that helps.
Basically the center and 2 that straddle it on either side.
Now, the reason why we slow down the vehicle is to reduce the re-entry forces, which helps us recover and reuse the first stage booster.
Ever noticed that when a rocket is counting down to launch, it feels so slow, but after it launches, if you blink and it's suddenly 2 minutes have passed? Yeah, no kidding. And of course, we saw the exhaust plume almost completely gone. I'm not sure if it's the cloud deck or what it was. The time from staging to fairing separation seems much shorter on Starlink launches. Evidently, SpaceX is willing to tolerate their Starlinks getting toasted a little bit more in the exchange for more mass efficiency. So basically, the minute they separate stages and then ignite the MVAC, moments later they actually pop the fairing off. They usually do that like right at the Kármán line or right before it.
Falcon 9 is the world's first orbital class rocket, reusable rocket, and this is important because
and meanwhile, the first stage is falling down, and they're about to start the re-entry burn at about 50 kilometers altitude. The first end of the center engine, number 9, will be lit, followed by engines 1 and 5, and it's going to be about a 20-second or so burn. They're going to be touching down on the drone ship excuse me, just read the instructions. Did you know that a booster for Flight 7 is going to reuse an engine?
Stage 1, FTS is saved.
Stage 1 is igniting the engines, and they also shut down the flight termination system because it is so far downrange that it's not a problem in case a problem occurs with the first stage.
Hoping to slow down the Falcon 9 booster as it's making its way back down to Earth.
They should be shutting down the engines momentarily.
Stage 1 entry burn shutdown.
They just called shutdown of the engines for the
and there we heard the call out as well, as you could see.
For the entry burn.
The entry burn for the Falcon booster.
They're going to have SECO 1 before the landing burn. SECO 1, that stands for second engine cutoff 1, where they shut down the second stage engine, at which point they will coast for a bit.
And that'll basically be where
landing record up to now? Oh, that's a good question. I think it's like 20 plus now. As far as the number of ones for a booster or total. Okay, stage 2 is in terminal guidance, meaning it's nearing the end of the first powered flight.
And just shortly after we have SECO, we'll also have the landing burn.
I believe so, yes. 25 landings for one Falcon 9 booster, yes.
Stage 2, FTS is saved.
And now, of course, the second stage they called subsonic on the first stage, or transonic, meaning they're in the regime that's between supersonic and subsonic. And shortly thereafter, it'll go subsonic. And they're about to light the center engine to put it down on just read the instructions.
SECO.
Stage 1.
They just had SECO 1 on the first stage. There's the first stage with the center engine lit. And you can see the grid fins also
Nominal
taking
orbit
part in there.
insertion.
They're calling nominal orbit insertion on the second stage with the payload. We see the drone ship on the below. There's a picture of the deck on the right.
Landing leg deploy.
They call landing leg deploy, and we have touchdown.
And there you could see on your screen, the Falcon has landed on just read the instructions. That marks SpaceX's.
That's the first time I've seen difficulties with the camera on the booster, and almost nothing no problems on the drone ship.
We're just waiting for confirmation of good orbit.
They already called nominal orbit. There are the payloads. Of course, I love a successful landing. Yep. That thing must be toasty. Yeah, indeed. See, also, of course, I love a shortfall of reading the instructions. Oh, dear. That's all 3 of those things represented in a single phrase. And it looks like we're on the day side of Earth now.
Again, we have had SECO, that is second engine cutoff 1 for that MVAC engine.
I wonder how much Delta V impact the soot buildup would have after 25 launches. I don't know. Never really thought about that. Gotta be at least 1 meter a second. Okay. You're talking about how much aerodynamic friction that stuff will actually cause.
And we have confirmed good orbital insertion.
And now we have a really good view of that
Just
manifold
yet.
now.
Coming up next, we have the
Because
second
SpaceX
burn
doesn't
of
clean
our
soot
Impact
much.
engine,
No, it
or
doesn't.
STS-2, on board the second stage around T plus 58 minutes. So, and then that'll be followed by a payload deploy. So until then, we're going to send it back over to you, Daryl, at KSC.
All right, thank you very much. If you're just joining us, we are just into the mission here. T plus 10 minutes and 30 seconds into the flight of the Falcon 9 with the Blue Ghost.
I guess that added mass on the first stage makes it that much less of a delta V penalty on the than on the second stage. I guess.
Live, right here from the Space Coast at Kennedy Space Center. And on board are 10 NASA payloads headed towards our moon. We have Ray Allensworth, who is here, the spacecraft program director. You and I were just out there watching it live outdoors, just 3 miles away. How'd that feel?
I can't stop giggling. No, I mean, it's one thing to watch a rocket go.
I probably won't be able to stay all the way until
it was perfect.
even the second burn of the when they relight the MVAC, and that's likely to at least load the lift the basically raise the orbit by quite a bit. Not necessarily at escape velocity.
Second stage engine burn that's going to help complete its trip to get you where you need to be around the Earth and into that orbital insertion. And then we're going to deploy at 1 hour and 5 minutes. So we're looking at
1 hour and 5 minutes. That's not too bad.
From now. And there's a lot more work to do. So make sure you stay with us. We are on top of it here with our team.
If it's T plus 1 hour and 5, I believe I can hang on to that for hang on for a bit.
And we're also going to nail that acquisition of signal right after it separates. So we're going to be expecting that about 6 minutes after launch vehicle separation.
I think an interesting stream idea would be discussing different space stories. Oh, interesting.
All right, we're continuing to track, and if everything goes as planned, in 45 days, the Blue Ghost lander will land at Mare Crisium, a large, dark basaltic plain in the northern hemisphere of our moon. The location is near the Sea of Tranquility, the landing site for Apollo 11. It's also near Taurus Littrow, the Apollo 17 landing site. Ray, NASA chose Mare Crisium as the landing site for a good reason.
Absolutely. The landing site was chosen by NASA because it supports the goals of our 10 NASA payloads that will gather critical data about the moon's regolith, geophysical characteristics, and the interaction of the solar wind and the Earth's magnetic field. The landing site also allows us to capture the lunar sunset after Firefly operates for a full lunar day, which is about equivalent to 14 Earth days. We'll be studying a unique phenomenon seen by Eugene Cernan during his final steps on Apollo 17, where he observed a horizon glow as the lunar dust levitated on the surface. On your screen is a sketch Cernan made of the event. Firefly is set to capture this phenomenon during the lunar dusk conditions and further prove what Eugene saw as the last astronaut to walk on the moon.
And you can see on your screen a live shot right now of the moon. This actually was recorded just a few minutes ago, but this is what it looked like outside when we were looking up. Such a beautiful shot, and big thanks to our camera crew for grabbing that. And if you look closely, you can see where Blue Ghost is heading, that landing site. It's in the 12 o'clock position. Correct me if I'm wrong.
Yep, at the very top of my very top of the frame there. That is where Blue Ghost is headed.
Beautiful shot. Blue Ghost is on its way. With us now, the Associate Administrator of NASA's Science Mission Directorate, Nikki Fox. Well, you saw it live in person as well, Nikki. And
I did.
Beautiful shot of the moon there. It's all coming together.
I know.
Skylab crew brought up a tape recording of one of their wives' voices saying she brought them up a home cooked meal and pranked Mission Control with it. Oh dear.
As well. You know that countdown goes, and you know it's.
Amy Shira Title actually has put one up rather recently of a rather risque checklist item.
I'm taking in all the moons.
Or at least a page of them.
I mooned out for you guys today.
You sure did.
I did, yes.
Oh,
yes.
It looks lovely. Well, let's talk a little bit of science now. How is the science and the tech on board this particular mission inspired by NASA's Apollo 11 mission?
Yeah, I mean, we learn, the great thing about NASA and about NASA science is we learn with every single mission that we do. And so, of course, we learned so much about the experiences of our astronauts on the moon. And, you mentioned before that the regolith is a big challenge. It's very sticky and it's very tacky and it kind of sticks to everything. And so we actually have a couple of experiments on there. One is going to sort of...
Did I ever hear the gorilla story? No, I hadn't.
That dust is...
And they're talking about the regolith that's on the surface of the moon. That has probably also been a point of concern for the EVA suits when they went up to the moon, mainly because it would tear at the various layers of that. They had plenty of layers of it without too, but it still was very much a reason for concern.
So we're going to look at how
at least both of the landers flying on this mission seem to have quite a wide base compared to the Intuitive Machines lander that fell over. Oh yeah, that's right, and hopefully this will actually be a successful one. An astronaut on the shuttle or Soyuz snuck a gorilla suit in their personal items and pranked the ISS crew by putting it on and floating at them. Oh my God, that's crazy.
About the conditions on the moon, about the geophysical conditions, about the solar wind interaction with the moon. We can't wait to get the science up on the moon. That's why we're such fans of the CLIPS program. It's like a geological sort of preserved record of what this ancient solar wind is like. You just need to go down a little bit into the regolith, and that's the preserved sort of surface interactions. And of course, it allows us to think about what we want our astronauts to focus on.
And not to mention, there isn't since there isn't any atmosphere on the moon and no wind to move stuff around on there, you won't that stuff won't weather, as it were. And that's one of the reasons why if you go up there, the footprints that are on the moon will likely still be there.
And briefly, it's a basaltic.
And on top of that, since that regolith is so jagged, it'll actually stick to itself and just stay there.
Well, I think Ray just kind of nailed it. I mean, it's a great place for us to go. It's a region that we think the astronauts will be interested. It's a really great place. Loads of interesting features. The actual area was caused by an impact from an asteroid. It flooded that area full of that lava. It's a very dark lava, very similar to what we have on Earth. It tells us about how the moon was formed, how the early solar system was formed.
Oh, Scott.
So it's just a really scientifically interesting place to go.
And Ray, you appreciate that there's no big rocks, hopefully, in that area, right?
Yeah, we're gonna avoid the rocks. Our software is gonna help us identify the safest place to land, and like you said, avoid those hazards.
All right, very good. Well, Nikki Fox, thank you for joining us today. We appreciate your moons. We appreciate the insight, and we appreciate your levity as always. NASA tends to be a serious place, but you bring the right.
I think that third burn happens after they deploy Blue Ghost.
Well, it's difficult work to get to the moon. We haven't successfully done it in more than 50 years, but that's going to change. The CLIPS initiative.
Ranks in Space could be a fun video. Apparently, human desire to do fun things is infinite. Yeah, indeed.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLIPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLIPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLIPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely.
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission, and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLIPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
All right, we've been going through each of the 10 payloads throughout the show, and now we've got a doozy. 5 of the payloads right now, and that's half of the ones going up to the moon. Joining us now is Dennis Harris, mission manager for those NASA payloads, and appreciate you being here.
It's good to be here.
Let's start now with the Lunar Planet Vac, or LPV, which collects samples of lunar regolith from the surface. This is really interesting. I mean, the name kind of suggests exactly how it works. Planet Vac.
It's like a vacuum. Yeah. They carry up their own compressed gas, blow down on the regolith, collect it, and then put it in a canister. And this is a tech demo, so the canister in the future can be used to return the samples to Earth, or it can be used to send to any instruments on the spacecraft for in situ measurements during the mission.
Yeah, if we wanted to bring it back, we could.
Correct.
And there you see it, Ray, as it's mounted there underneath the Blue Ghost. Tell me how you had to account for this thing, which is touching the regolith.
Absolutely. So this payload, obviously they're a vacuum. They really needed to be in situ, touching the regolith. So it's on the bottom of that surface access arm that we talked about earlier that's also carrying EDS. And so when we land on that lunar surface, that surface access will go down, and their sample collection head is right at the end. So it'll press down into the lunar surface and then collect dust onto a sample sorter that we placed on the top deck. So it's another payload with multiple components that we placed kind of strategically to help them accomplish what they need to.
Maximizing that lever arm that you're putting down on the surface of the moon. Yeah.
Pack them all in.
Right. Okay. Well, next up is LEXI, the Lunar Environment Heliospheric X-ray Imager. LEXI is a wide field of view, soft X-ray imager that will image Earth's magnetosheath and magnetopause to study how energy from solar wind generates geomagnetic storms and space weather. This one's interesting to me because this is looking back at Earth rather than looking at the moon.
Correct. And as Brian Walsh, the PI, said yesterday,
like
the first global measurement.
Like the late William Anders said, we went to the moon. We went to the moon to explore the moon, and we discovered Earth.
Well, this is where the solar wind meets the magnetosphere, and what happens is you see the bright yellow and red spots. They're giving off energy, and so we're going to look at the photons, which happen to be in the frequency of soft X-rays, to see what's going on.
What a unique area to look at that, and I take it, Ray, that it had to go on top, right, in order to look up.
Yeah, this payload Very top deck. It's also mounted on a 2-axis gimbal. So this is a gimbal that we really specifically designed. Yeah, you can see it there. So that Lexi can look back specifically where it needs to collect that data. So a pretty intricate gimbal, but I think it was a lot of fun for the engineers to kind of solve that problem to get Lexi pointing where it needs to.
That's cool, that 2-axis gimbal, a solution coming from Firefly. You got to appreciate that.
We do.
All right, well, this instrument that's next is, we have a demo right in front of you. A RAD PC. This is a radiation-tolerant computer system. Dennis, why do we need radiation-tolerant computers?
Well, radiation is a killer for computers. Ionizing radiation could cause a bit flip, could crash the whole system. This particular system is going to use a set of 4 CPUs to kind of count each other and make sure each other's, there has been no single events. And so if it senses...
Yeah, they have to harden a lot of these ones, especially the ones that go on interplanetary missions. Going into cis lunar space probably isn't as bad as, say, going to, like, say, Mars or points further away. But certainly outside the solar system, you definitely want to have that because you got a lot of cosmic radiation coming in, and that's probably what the Voyager probes are also experiencing is failures owing to all that hard radiation that's out there.
I like that. That's good stuff. All right, 3 down, 2 to go. Next up is NGLR. This is the next generation lunar retro reflector, right? And it's a target for laser.
Oh, there's one that was actually left there by one of the Apollo missions, and that's how
that works right there.
Well,
let's look at that.
Range finding observatory on Earth is going to shoot out a laser pulse. It's going to hit this, and it's going to return it. And the nice thing about the next generation is it's built so it's going to return the ray to where the observatory is going to be. Not where it was, but where it's going to be on the Earth. So this is going to allow...
Jupiter is apparently particularly bad in terms of needing radiation shielding. Its magnetic field traps a lot of energetic particles, if I remember right. That does sound right, yes.
Apollo retroreflectors. Some of the same team that put the Apollo retroreflectors on the surface are working this program as well.
Oh, wow, that's pretty cool.
And worth mentioning, in 1969, University of Maryland physicist Doug Curry helped design 3 still-in-use lunar instruments placed on the moon by Apollo 11, 14, and 15. And he worked on this one.
He is the principal investigator, yes, Dr. Curry.
How about that?
Well, it's a lifelong passion for him, and I really appreciate his knowledge.
And you got to work with him on it.
Yes.
Pretty basic in terms of installing this, I would take it?
Yeah, this is our only payload that doesn't have an electrical interface. So this is purely a mechanical interface that is also on the top deck on one of those 2-axis gimbals. So we loved NGLR.
Right, very good. All right, and last but not least, we have the regolith adherence characterization, or RAC. Now, I kind of like this one because of all the different samples that are on board. It's going to determine how lunar regolith sticks to a range of materials exposed to the moon's environment. So there it is. What are all those little circles on the wheel?
So those are all different material samples. So some are spacesuit materials, some are optical materials, some are Teflon, some are aluminum. As Nikki was talking about, lunar regolith is really not good to work with. And so what we want to help determine here with this experiment is what kind of materials can we use in the future? What kind of changes can we make to, say, spacesuits or the equipment we put on there to help them, live longer and survive the regolith.
And you want to get it dirty.
Yeah, and on top of that, the astronauts are having a lot of difficulty walking.
All the radiation can get.
I love how I don't know what to call it.
So how'd you accommodate?
I love just how I don't know how to what to call it. Durable. We managed to make a bunch of equipment that we've got shot into space. Yes. That especially anything that any of the computers that go up there and all the electronics and stuff like that, they really have that down to practically a fine art. And of course, I mean, all the technology advances quite a bit.
Is there anything you can do to help it out?
I think a lot of the other payload ops will help it as well. Maybe we'll toss a cold gas thruster their way if they need a little more. We'll play with that. But they should be able to get covered pretty well.
There's literally a negotiation going on right now.
But yeah, the whole material science stuff, or the of having to deal with the regolith, because that is going to be a constant problem when they go up to the moon, because like I'd mentioned before, it did not do the EVA suits any good. That coupled with the fact that at times the astronauts were having trouble just walking on the moon.
The teams that worked on them have worked hard for the last.
Voyager had a magnetic tape system for storing data, and now that how that tape hasn't annihilated itself by now is beyond me. Well, it's not. It may not necessarily even be plastic-based tape such as polyester or mylar. Mylar being a type of polyester or acetate, which was another material they used for that. But they probably might have used an actual metal backing, or the actual tape itself might be the magnetic medium. It's both the coating and the substrate.
Back in the early 50s, she had a scholarship to Montana State for an engineering scholarship, which unfortunately she couldn't go, but she then jumped into the Navy came out as an electronics tech. So maybe that's where my interest in engineering comes from.
She must have been proud watching that rocket fly with your 5 missions aboard.
She was.
All right,
Yeah.
Dennis Harris, thank you very much for joining us. Appreciate you taking the time, and good
Thank
luck
you.
with all of the payloads.
And good luck to you guys.
Thank you.
Really looking forward to it.
All right. Well, now we are going to step aside while we await our next big milestones, the second burn of the second stage of the Falcon 9 rocket, and then the separation of Firefly's lunar lander from the SpaceX second stage. Now, we're going to return for that and more in about 20 minutes. We'll have more payloads. There's 2 more left if you've been counting. We're going to talk about those. We'll also see that tremendous video as we watch Firefly hopefully release from the second stage and drift off into space. That's all coming up in a bit. Again, 20 minutes from now. Hope that you'll come back and join us. Take a little cat nap. We'll be right here, and we'll see you then.
And I'm actually going to mute this for a minute. Anyway, but yeah, like they were saying, a lot of the, like I said, the one that got me interested, now that I'm really interested, is the whole material sciences thing, because you'll sometimes see the videos where the astronauts are having locomotion issues on the moon, because the moon's gravity is a sixth of that of Earth, and they trip and fall, and the big worry, of course, is all that regolith would be tearing into their clothes, potentially ripping a hole open to the point where it could start letting their atmosphere out. Because it isn't just the oxygen that they have to worry about; it's the fact that you have partial pressure on all those gases. And here we go. Here we got a nice view of the spacecraft bathed in the sun. And there's that manifold that I mentioned earlier that comes off the turbopump exhaust, sending exhaust gases into and then there's the payload, and you see some thrusters on the thruster quads right against the a vehicle right there. And it looks like we see the landing pads too. And basically that manifold directs some of that exhaust gas into the nozzle. Basically providing a film that's sort of a boundary layer sitting between the inner part of the nozzle and the flame that's coming out of the combustion chamber. And it's interesting how they're always saying that this is the most energy efficient hydrocarbon fueled rocket engine around. Was it something like 340 seconds for specific impulse? I forget. And of course, ultimately, liquid hydrogen is the ultimate winner because it is so undense, for one. And two, there's so many different ways to make hydrolox engines. They have all those different cycles. Like you have the usual open cycle that the RS-68A uses. The fuel-rich staged combustion cycle that the RS-25 uses, and the oxidizer-rich staged combustion cycle many of the Russian/Soviet engines use, and now the BE-4 uses it, and of course you have the whole kit and caboodle together in the form of full flow staged combustion in the form of Raptor. And right now, Raptor is the only full flow staged combustion engine that has actually flown. There have been tests of another one, I think, but this one's the first to actually fly. And of course, the real dilemma right now is how do they take basically a lot of fuel and oxidizer into orbit for a refuel. Wikipedia says 348 seconds for the current vacuum Merlin variants. How does that compare to the vacuum optimized rich stage combustion engines? That's a good question. I don't know how many how many of that particular class are. I don't know, like for example, what the I believe the center engines on the Soyuz. I know they're lit at ground level. They're lit at ground level and are lit for most of the ascent. With of course the four outer ones also lighting at the ground, but usually getting tossed off in the Korolev cross about 2 to 3 minutes into flight. I forget the exact Soyuz flight profile because I haven't covered Soyuz flights since early 22. And I wish I had something to drink because, man, my throat's starting to get a little dry. But yeah, I knew it was in the 340 some odd neighborhood as far as specific impulse for the Merlin 1D engines. And from what I understand, that is actually seems like the RD-0124, which flies on the upper stage of some Soyuz launches, gets 359 seconds. And yeah, that uses TG1, which is the Russian equivalent of the RP1, which is, of course, rocket grade kerosene. Hey, Cabbage Bun, how are you? Good to see you. Hope you've been enjoying the stream thus far. Let me check this to see if there's anything on that one. And meanwhile, I just unmuted the cart wall, so we at least have some music in the meantime. Or at least made it visible again. I need to actually put that on my Stream Deck so I can actually change visibility of that while this is going on. In fact, I could probably do that right now while we're doing that. Ignition by John D. Clark has some great context on the workers trying to get jet fuel in a rocket engine. Turns out the standardization matters a lot more for rocket engines. Standardization for kerosene mixtures. Yes. Yeah, that's why they have much higher levels of refinement for RP1 versus say diesel number 2, which of course is or even Jet A. And then of course you have completely different grades of jet fuel. And on top of that, there's even for the military, there are different grades of jet fuel. Like for example, in some cases, I know I can't remember whether the Navy actually adds this additive. Hey, Noodles, how you doing? Work, I come to Peaky. Thanks for coming in. Basically, we're watching one of the earliest commercial flights to the moon, where they start doing cargo delivery to the moon, like to do sample collection or anything like that. And they lifted off on time, and they're right now in a coasting phase. And then they're going to do an orbit raising burn of the second stage to put it on its way to the moon. Yeah, something like that. Now, a lot of that will also come in handy for the forthcoming Artemis missions that will ultimately land people on the moon for the first time since 1972. The alkenes is less refined in less refined flavors of kerosene. Don't usually cause that many issues in jet engine applications, but apparently their propensity for polymerizing is great for clogging rocket engine components. Yeah, that's one of the I think that's one of the biggest issues when it came to when it comes to basically what they're talking about. What that is that they're talking about coking, or basically turning it into a sort of a goopy substance that goes into the injectors, especially particularly in any Carolox engines. With orbit thingy, we are using Earth to pull a toss into the moon. Yes and no. First of all, it's in a sort of a parking orbit right now. It's basically in the orbit right now just to get itself ready to be pushed to the moon. The second stage, which is the upper part that uses a lot, that has only one engine on it, got it to the speed that it's at now, which is a little bit under 27,000 kilometers an hour, or about 17,000 miles an hour. And what they're going to be doing with that is they're going to be firing up the engine again in a bit, so then it can raise the orbit, sending it further on to the moon. And what they usually do is they do it just enough so then it goes out there, and they only need small little burns from the engines that are on the actual lander itself. But in order to get people to the moon, they take a far more direct approach. They send it off to the moon, and then once they get close enough, they turn the whole vehicle around, burn the engine for a few seconds in order to basically slow it into lunar orbit. They're still going forward. They're still going in the same direction the whole time, but they have to slow down just to get captured into lunar orbit, and that way they can then land in the Lunar Excursion Module, or a LEM. Yeah, something like that. That's an interesting way of saying that, because the basically when you see if you've ever seen some of these those movies of like, for example, one of the Lunar Excursion Modules take off from the moon, you'll see these little pop 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 pop, or even the Crew Dragon, as it's backing away, you'll see these little flashes. Sorry about that. I had to cough, and I didn't want to make you guys suffer through that. But basically, you'll see these little pops of firing. Those are thruster fires that they don't put a whole lot. I mean, they put quite a bit of it into it, like a few pounds, worth of thrust. But those few pounds can sometimes make a difference. But yeah, that's basically it. Those little maneuvering thrusters are just tiny little engines spraying out a very an energetic mixture of in the case of many of these, it's going to be a rather interesting concoction of two very, very dangerous chemicals. One, it's an extreme carcinogen, and the other one is very corrosive. Both of them are just outright poisonous, and that is one's a hydrazine of some sort. Nowadays in American stuff we use monomethyl hydrazine, whereas in Europe they use unsymmetric dimethylhydrazine, and of course dinitrogen tetroxide, which is the oxidizer. That's what is called a hypergolic mixture, where when those two come in contact with each other, they immediately combust. When do we get to see the change after orbit? Also, will we see the live feed? Yes, we're hoping for that. It should be. They stepped away for I'd say about 10 or 15 minutes ago, and we should be seeing that coming up in the next 10 to 15 minutes here. And usually on a long range insertion, a high delta V type burn, it's probably going to be at least a minute, maybe 2 minutes. Good, cool, Ulrich. Cool. Good to have you here, as always. But yeah, they were one of the things that they were talking about is all the what they've been talking about are the various payloads that are going up there, including the one that like I was saying earlier, was a very interesting material sciences one, where basically they have this wheel that has swatches of various materials, including materials that are used for like lenses, stuff for like spacesuits and stuff like that. Also forgot to greet you. Happy New Year. Thank you. Happy New Year to you too. So basically, what that does is they're finding out the sort of sand-like substance on the Earth called regolith, regolith. Basically, is this? It tends to stick to everything, and in the case of the Apollo astronaut spacesuits, it was really, really, really bad at sort of cutting into the fibers on their suits. And the biggest concerns is that they don't want to cause too many holes to form and possibly depressurize their suits. They weren't out there for that long, but certainly long enough to be a concern. So I'd say about another 10 or hopefully we'll see on the other side where they have the interesting the stuff that's coming in via telemetry, showing the speed and altitude. We hopefully will see something coming over the on that curve, basically saying the next moment on the timeline, which will be what is called SES2, second engine start 2. And then, of course, that engine will burn for a bit, followed by SECO2, or second engine cutoff 2. And shortly thereafter, after they made sure that everything is stable, they will go ahead and let go of they will deploy the load, let it go and float away. And it will be and it'll start making its way to the moon. It'll be there in about 45 days. Basically, they don't do, here we go. Hang on a sec here.
Second burn of the second stage of the Falcon 9 rocket and separation of Firefly's Blue Ghost lander from that second stage rocket. It lifted off at 1:11 and 39 seconds a.m. Eastern Time. I am joined by Ray Arnsworth. He is the spacecraft program director at Firefly. Been doing a fantastic job. We watched the launch live. It took off. You said, bye, honey. This is a spacecraft you've been working on for so long, and then you saw it take off, and now we've been flying for about 47 minutes. What's your sense of how the team is doing, and how are you doing at this point?
My heart rate's come down a little bit. It's definitely very special to see it go. I think the team now, especially that team back in Texas, really this is where they're locking in. So, we're about to go into payload deployment. The lander's powered off right now, but it will soon start that automated sequence to power on. So this is really where we start. So just a lot of anticipation building.
A shot on your screen now of that team that you're talking about from just outside Austin, Texas, the Firefly Aerospace Mission Operations Center. And the team is all there and, as you say, focused on the next steps. The company is, of course, based in Texas. They developed and built the lunar lander that is carrying, among other things, 10 NASA payloads. And if everything goes as planned, in 45 days, that Blue Ghost lander, which is uncrewed, there are no people on board this is purely a robotic mission. If everything goes as planned, it's going to land on Mare Crisium in the northern hemisphere of our moon. It's an area that, of course, NASA wants to study and was chosen specifically for that reason.
Yeah, absolutely. That place, Apollo has visited there. We also believe future missions will want to go back there. So it's a really important place to go, gather data, and just prepare for what's next.
We still have a few more NASA payloads to cover throughout the show. We've talked about 8 of them. And now, finally, the last 2.
Last 2.
You ready? All right. Let's talk about it. And it starts with LUGRA, an acronym for Lunar GNSS Receiver Experiment, which was developed at Goddard Space Flight Center. LUGRA is one of the very first demonstrations to test GNSS signal reception and navigation on the lunar surface, right? These are satellites going around the Earth, but we're using them to develop location on the moon. GNSS is the Global Navigation Satellite System, which is commonly thought of as GPS. Of course, that's the American Satellite System nomenclature for it. If successful, this would pave the way for operational use by future lunar missions, such as the Orion spacecraft.
European navigation satellites are called Galileo, and Russian is called GLONASS, and Chinese is called the character like you hear from Genshin Impact, Beidou.
That'd be really amazing in the future. Quite like use your phone, pull up Apple Maps, Google Maps. You want to put in a place, you go exactly there. That's the future of what could happen on the moon.
And that's pretty cool. That would be an advantageous thing for anything going to the moon, right? How did you?
There's SES2 coming up on the
so LUGRA is
coming up on the timeline.
Deck. It's on one of those two-axis gimbals. So LUGRA shares a panel with NGLR. And this is a really special payload. This was in partnership with the Italian Space Agency. And so, yeah, we're excited to have that and get it operating.
First equipment
and SES2 is coming into view as well.
On the surface of the moon, we know they are
excuse me, SICO2.
Let's talk about our last payload now, the final one. This one really kicks in right about the end of, right when they were landing, right? As it kicks up a plume. It's SCALPS, and it stands for Stereo Cameras for Lunar Plume Surface Studies. It was developed at NASA's Langley Research Center in Hampton, Virginia. SCALPS is an array of cameras placed around the base of the lunar lander to collect imagery during and after descent. Those images will then be compiled to produce a 3D view of the surface, and not just for the novelty of it. As trips to the moon increase, the number of payloads touching down in proximity to one another will also increase, and you see it there as it's mounted on the,
that's interesting.
The Blue Ghost lander. And
basically, they don't want to. Basically, when things start to land closer to each other, they're going to start kicking up more and more dust.
Of landings and how much of that regolith, which we know is harmful, gets kicked up on instruments and equipment.
Yeah, absolutely. SCALPS is really going to be gathering so much data. It's the only payload that's powered on during descent. And just like you said, is exactly right. It's gathering data. It's seeing the lunar surface, what happens right before, at, and after landing. So SCALPS has flown before on a previous mission. This is their second time. We're excited to fly them. It's our first time with them, but it'll really inform all those future missions when they go to land on the moon.
All right, very good. Thank you, Ray, for the breakdown. Blue Ghost will deploy in about 15 minutes from now. And Ray, what can you tell us about the journey it's going to take to the moon?
So the journey to the moon is going to be elongated. It'll be 45 days in orbit. And we really want to keep everybody updated with us as we go along this journey. So we'll be doing daily updates on our mission page and our X channel. We'll also be doing weekly updates. And so these will be updates coming from the Mission Operations Center. And we'll release them on Thursday afternoon on our social channels. So we'll really want everybody to kind of go with us on this road trip to the moon.
Video updates from the team, not video of the moon.
Correct.
That will come later. But this will be a really great way for you guys to engage with the audience and show them the progress that you're making.
Absolutely. There are going to be times during orbit and the surface where we'll share photos and videos, but these weekly video updates will really be coming from our Mission Operations Center, from those engineers that are operating the spacecraft.
All right, looking forward to that. Spacecraft separation will be just the beginning for Blue Ghost. Here's more on what we can expect on Blue Ghost's mission to the moon. right, joining us now to talk about NASA's reaction to the progress Firefly Aerospace has made so far in the Blue Ghost mission is NASA Deputy Administrator Pam Melroy, former NASA astronaut as well. Thank you so much for being here. Well, you were here for the launch. You watched a beautiful launch. Your reaction?
Wow. Well, I think it's easy to forget at a moment like this how much work goes into, how many things have to go just exactly right. So I'm excited. My congratulations to Firefly, to SpaceX, to the NASA team, everybody who played a part in this, including the people who put the instruments on it as well. There's a lot of work to do yet, but it is just amazing to achieve this, and it was such a gorgeous launch.
Right. I mean, beautiful. You had the moon up there, nearly full of waning gibbous,
Yes.
97%.
Yes.
Want to make sure we get that right. But yeah, and then you could see it. It was such clear conditions.
Yeah, and I think what's interesting is I've seen so many launches that were going to the space station, and
no, I'm sorry, my thing was off again.
And they're gone, and so the trajectory is just so noticeably different.
I don't know if you guys were hearing me.
You're like, oh yeah, this one's going somewhere else.
Darn it. Anyway, I think I was touching things like I wasn't supposed to be. But anyway, yeah, like I was saying, it's the regolith can be pretty nasty on cloth and optics and stuff like that. And on top of that, on the vehicles themselves, especially if they have to make a return trip home once they're done doing their mission on the moon, the regolith is nasty.
To the Firefly team about the work they have ahead.
Yeah, well, this is a great
moment. No, the VTubers is not picking up any of the video sound at all. Everything's pretty much on isolated circuits. Not real circuits, that is.
This is incredibly hard.
They're talking about stuff that's created by, like my mixer, in this case, voice meter.
Congratulations for getting where you are, but keep your eye on the ball because you got a lot of work going. But I think one of the other important messages is we do this as a team. This is a team sport. And so the collaboration within the Firefly team, but also with your partners is really important. NASA has your back. We know that we're all doing things for the first time. So we just have to work together to solve any problems that come, and then we'll be successful together.
Great words. I know that you must appreciate hearing them.
Yeah, one of the things I was dealing with is I have a new set of Stream Decks, one of which is a Stream Deck Plus. It has knobs as well as a touch strip on there, and my finger must have been too close to this to the touch strip where it was actually muting this mic.
Refocus and start our mission.
All right. Thank you very much, Deputy Administrator Pam Melroy, for being here. You are with the outgoing administration. Your time at NASA, we really appreciate your leadership here and all that you've done and coming to these launches and being a part of these launch broadcasts. Thank you very much.
Thank you, Daryl. It's a great way to go out.
They're coming up. They have engine start, second engine start 2 right now. I wish we had some video of it.
In Hawthorne, California, where Jesse Anderson is live as we await that second burn. Jesse.
And there it is. There is the second engine. The second engine start has happened, and there's the engine is burning.
Screen in that second burn, SES2.
And of course, you can see the velocity is increasing considerably.
This burn is a very short burn, and we've got live views of the NVAC engine there, ignited on your screen again, carrying the 2 lunar payloads on Falcon 9's second stage. This burn will last just over a minute long.
So it is about a minute, and then after that, it will shut down. It will coast a bit.
On the MVAC engine is about 220,000 pounds of thrust. So even though this burn is only a minute long, it provides a lot of thrust for the vehicle to carry those payloads to its targeted drop-off orbit. Again, this is
and we have SES2, SECO2, second engine cutoff.
The MVAC engine for this mission today.
And now we got about another 15 minutes until payload deploy.
Perfect.
Hard to fathom just how fast it's going. Yes, that is true.
SECO2 of that MVAC engine burn, and we also heard that call out for confirmation of good orbit. So it looks like we are on track for the first.
Oh, look at that! That is a beautiful view.
In just a few minutes from now.
It's also unfathomable how deeply black that view of space is. I mean, you get that even at 70,000 feet. because you're so, and because I was watching this video that James May of Top Gear fame was in an a U-2 spy plane, a two-seat trainer, talking about how when he was at altitude, a vast majority of the atmosphere by mass was below his position.
Blue Ghost coming up here in just about 4 minutes from now, and once deployed into
It's actually it's a little sooner than that. I'm sorry.
Lander will begin its approximate 45-day journey to the moon, where it will land on the Mare Crisium for NASA's payloads to perform numerous science and technology demonstrations, including lunar subsurface drilling, sample collection, and X-ray imaging of Earth's magnetic field to advance research for human missions on the moon and provide insights into how space weather impacts the planet. So very exciting coming up here. Again, Blue Ghost deployment is coming up in just under 4 minutes from now. And just to recap the mission so far, we had an on-time liftoff at 1:11 a.m. Eastern Time. And everything has been proceeding nominally. We had a good stage separation, which occurred about 2.5 minutes into flight. That was followed by a successful landing of Falcon 9's first stage on our drone ship. Just read the instructions. And that was also
and
the
we
fifth
see those
flight and
thrusters
landing
again
for the specific booster that supported tonight's mission. And for those of you following along, that booster also supported NASA's Crew 9 mission, RRT-1, as well as 2 other Starlink missions. Now, just before the
is it going to break apart? No, it's what they're going to do is they're going to actually separate the top that particular payload away from the top of the second stage, and it will float on its own.
Second stage engine. The second one again just completed just a few moments ago.
And then those thrusters will probably be fired every now and again just to correct the course as it goes on its way to the moon, raising the orbit. And they don't need that much in the way of Delta V now. Much of that was given by the actual second stage of the rocket itself.
An awesome live view of the Blue Ghost spacecraft on board Falcon 9's second stage. We're just about 2.5 minutes from deploy of Blue Ghost. And this is a cool view. We do have the canister just below that spacecraft protecting iSpace's payload there. So we do have 2 payloads on board. But again, the next milestone coming up is that separation of Firefly's Blue Ghost.
I don't know if they're going to continue the coverage or not, but I'm probably going to end my coverage in a little bit, mainly because I have to get ready to go to bed. But this is the big one right here.
Just as a reminder, once Blue Ghost is deployed from Falcon 9's second stage, it will have about a 45-day journey on its way to the moon, and then it will have about 14 days of lunar surface exploration. So this is a pretty exciting mission. Very excited to see the spacecraft begin its journey here in just about 1.5 minutes. And once again, there you can see a live view of Blue Ghost there on your screen, still attached to Falcon 9's second stage. We're anticipating deployment in just about 1 minute from now. I'm getting some really awesome, cool views. This is looking aft at the MVAC engine with a beautiful Earth in the background. These lunar missions are really cool because the Falcon 9 vehicle gets to get really far away from Earth, and we get these awesome Earth views.
And of course, there were a lot more of those views during the Artemis mission, the Artemis 1 mission back at the end of 22.
We are approaching deployment of Firefly's Blue Ghost here,
And there you got a good view of the where the turbo pump goes out and into that manifold, which feeds into the interior of the nozzle. Oh, I see. Oh, wait a minute. The deployment is not that far off. The second one is, that is.
With these live views that you're seeing here, we should be able to get a really good view of deployment here.
Standing by for the first deployment of the first payload, which is the Blue Ghost lander. Here we go. Standing by. There it goes.
Firefly Blue Ghost, separation confirmed.
And there you could see, and you also heard the call out for confirmation that Blue Ghost is drifting away from Falcon 9's second stage.
Yep, bye-bye.
Here at SpaceX, it has been a pleasure having you on board, Blue Ghost. Safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services initiative to deliver science and technology to the lunar surface. And we want to thank Firefly for entrusting us with today's historic
Operation.
All right, thank you very much, Jesse and the SpaceX team.
FC com on ops.
Wow, what a ride. We're listening in
First
now.
command at 3.1 is to enable carrier.
Comms go to enable carrier.
FC, please enable carrier.
I think we're hearing stuff from Firefly Mission Control.
Center team.
All comms be advised, SpaceX has delivered the separation state.
Flight FC, I confirm that I see carrier enabled.
Copy.
Comms confirms carrier is enabled.
All right, Ray, this is your team. They're talking. You got the flight director in there.
Concepts 3.2, 3.3. Please verify at your discretion.
Right. So
tell us what they're saying.
So right now you're hearing the team go through the steps that are required to power on the lander and determine its position relative to the sun and make that first communications contact. So those mission operation controllers just outside of Austin, Texas are going through that process. It's an autonomous process. That'll take several minutes. And so, the spacecraft right now is approximately 848 kilometers away from the Earth. And they're going to start pinging that lander as it's going through this autonomous process. So we'll be able to hear that.
Before we're in range of the Hawaii ground station. And then in approximately 50 minutes is a per number event that FIDO will update.
Right, so he's talking about that first ground station that we're going to make contact with. That's in Hawaii. So they're configuring that ground station to be able to make contact with the lander.
And to be clear, you mentioned they're getting ready to power up, but they have to establish that communication first, right?
Absolutely. So that autonomous process will take several minutes. So that's the power up process. And then they'll start sending what we call no-op commands to the lander. So it's just pinging the lander about every 60 seconds.
All comms be advised, we would drop off nominally.
And then we're basically just waiting for that kind of handshake, that just acknowledgement from the spacecraft that it's hearing us.
And that was a good call out as well, that they confirmed.
PD or FIDO, if you do have the correct separation time, please comment in the logbook.
That SpaceX dropped you off exactly where you needed to be in orbit at 1 hour and 5 minutes.
Yeah, so that's definitely a really important check. Figuring out exactly where the spacecraft is step one. And then once you get your orientation, it's really forming that baseline of where's the spacecraft, what state is it in, and then moving forward from there.
is available for the trajectory.
Copy FIDO, please comment the expected penumbra time as well in the logbook.
So you hear Jackson there. He's our flight director, kind of walking the team through those initial steps of gaining signal.
And we jumped right into the work.
The file is ready, and we are working on commenting in the logbook right now.
That the Firefly team is doing in order to get that signal. We barely had a moment to soak up that separation, so we're going to re-cue
And that second deployment should be happening. I hope you get some video of that.
As the sun participated in a little bit of drama as it separated to go to the moon.
Yeah, you couldn't ask for a more.
There's a replay of the separation there.
Sun in the background. Look at it go.
Sunburst.
It's beautiful. I need a frame of that. But yeah, you see it. I think how she stated it's drifting away. It's kind of a
The second deployment, there is a second lander that's in there, a much smaller one apparently.
That was an incredible shot.
The sun.
Yeah. You couldn't have intentionally frame that up any better with the sunburst. Just
we planned it exactly that.
Well done.
Thank you.
Well, the team is continuing to work, and we heard
they were basically talking about two main payloads.
And have talked about throughout the show that this is the moment where the Firefly team really engages, the moment to acquire the signal from the spacecraft. If you're just joining us, we launched at 1:11 and 39 seconds a.m.
More or less. I'm not sure if they're going to be going to the same landing area, which is that sea north of Sea of Tranquility.
Then we traveled, did a couple of burns for about an hour and a half, flying with various coast phases in between there. And then you just saw the separation at 1 hour and 5 minutes. And now, myself, Daryl Nail with NASA, and Ray Allensworth, Spacecraft Program Manager with Firefly, are listening in to the communications that the team is doing as they work to acquire the signal.
Yeah, and this signal, it can take anywhere from between 5.
Just needed similar final orbit parameters, I guess.
That is considered nominal.
And they can navigate to the moon on their own from there. Yeah.
So, like you said, the team it's now time to lock in. They're all focused. They should start getting data very soon on those consoles.
And we're going to stay with it for a fair amount of time.
The path to the VSP is available in logbook.
We're going to stay with it in order to see if we can get an early AOS, but understanding, as you mentioned, that this is
AOS being acquisition of signal, and the next deployment should be coming up shortly. Let's see if we get a visual of that. They may not have one, owing to where it is in relation to a ground station.
Have to get the spacecraft in the right spot, lined up with that first ground station in Hawaii. So there's a little bit of margin as to when exactly that'll perfectly line up. Like I said, anywhere in that time frame is considered nominal. But we'll start pinging that lander soon as it goes through this autonomous power-up process.
Let's talk a little bit about the path ahead. Once, assuming we get an AOS, what happens then? What will we see happen in the next few hours and then days?
So when we get that acquisition of signal, there's some very initial...
All be advised, SSC has AOS standby.
Oh.
They just called AOS?
That was AOS.
How about
Incredible.
The vehicle has powered up and is receiving, and apparently it is alive and healthy.
Flight GNC and ops, I confirm we booted in safe flight and idle mode, just nominal.
Good. Okay, good. They took a minute to clap and...
Call out step numbers that you can verify in procedure 101.
And so, just a brief moment there, you saw your team applauding. I mean, you're feeling it too.
Yeah, I think I might have just had a heart attack. No, that's a great feeling, and wow, like we're talking to our lander in space, and we're officially going to the moon. It's insane.
That happened fast, right?
It happened fast. That's a great acquisition of time, acquisition of signal time. So that couldn't have gone better.
It has been incredibly smooth from beginning to end so far.
Anyway, I'm going to go ahead and call this a stream right now, mainly because I got to get ready to go to work in the morning. So in any event, I'd like to say thank you so much for joining me. Let me, hopefully tomorrow night sometime tomorrow we'll catch at least the, as always, no problem. Tomorrow night, hopefully, fingers crossed, that NG1 will actually lift off as planned at about 10 o'clock tomorrow evening. Although I imagine they're going to be moving stuff further and further into the launch window like they did last time. And of course, during the day, also they're going to be doing, I believe they're going to be doing IFT7. And I might do that as a replay. We'll see how things go and how things look on that. But in the meantime, and as always, I'm going to see what I can do as far as other stuff during the course of the week as well. But I don't think I'm going to be doing much of anything tomorrow other than covering of any space flight that happens to come up. But I count myself fortunate that I was able to do do some spaceflight coverage this week because, and on top of that, earlier today, SpaceX launched Falcon 9 carrying a bunch of stuff to sun synchronous orbit on a basically a rideshare mission. Let's see. I'm just seeing whom we might go visit and say hi to. Yeah, and also another thing I'm gonna try and see if I can find out more information about before too long, and that's how my new model is coming along. For those who don't know, I have a new model that's in the works. Art was done at the end of November, and rigging is ongoing. More information on that, I hope, before too long. Yes, indeed, I am looking forward to it. Let me tell you, that has been a something I've been wanting to do for a while, and I'm finally getting it. I just don't know precisely when. Like I said, but then again, one of the things I knew going into this is that these things take time. Let's see. I'm going to check something real quick here before I go too far. Oh, why don't I think we're going to go visit Scott Manley. He is ZYG. I think he is doing some stuff that's coming up for the next mission. And we will, he does a lot of stuff on YouTube. Amy Shira Title and Tim Dodd, the Everyday Astronaut, are some of my favorite YouTubers for things space and cosmology. So let's go give him a big hello. And we'll go ahead and start that. We'll go ahead and start that raid. And as always, thank you so much for... Let me go ahead and do one other thing real quick. I haven't started the raid just yet. Let me do the usual things. Here's some raid text for those people. I guess it isn't going to send it to me. I need to go check and see what's going on with my stuff over on the controller machine. No, actually, I need to use a web browser to look at it. My bad. Initializing. There it goes. Let's try that again. I'm going to go back to... Let's see. There's our raid text for those people who don't have subs. And for those who do, here is here's something with one of my emotes on it. And I've rated him before, and he is one of my favorite. He is one of my favorite YouTubers when it comes to, like I said, anything spaceflight and cosmology and astronomy. He talks a lot about the near Earth objects, I believe, and it is really interesting stuff. So in the meantime, we're going to go and say hi to him. And as always, thank you so much for joining me, and I'm so glad you guys could come and watch the launch with me. And in the meantime, as I always say, Slava Ukraini, and I will see you the next time, hopefully tomorrow, with a replay of IFT7 if it flies, and hopefully to cover NG1 when it does, assuming it does. And I hope to see you next time. Have a good one in the meantime. Bye.